For the topic natin is derivative na tayo. For the last meeting, ang discussion natin is with the limits. Yung limits na mga discussion natin, yung mga lahat ng mga rules natin for the limits is magagamit pa rin natin siya for the derivation. For the objectives, we have at the end of this session, you will be able to understand the definition of derivatives and the use of the rules of differentiation in computing for derivatives. Okay, for this topic naman, yung mga i-discuss natin for today, or yan, we have the definition of derivative, the differentiation formulas, and yung product and quotient rule. Pero i-start natin siya, ipapakita muna natin kung paano tayo mag-solve ng long term. And meron din tayo yung sa shortcut natin kung paano tayo mag-solve ng shortcut. Kasi kada derivation, like for this topic naman, yung product rule, meron naman siya na shortcut, and yung quotient rule, meron tayong shortcut. Okay, for the definition of the derivative, we have here yung instantaneous velocity of an object is equal to A. X is equal to A. We have yung limit approaching, yung X natin approaching A, we have f of X minus the f of A over the X minus A. And for with a small change of notation, this limit could be written as limit X approaching, where yung H natin is approaching 0, we have the function or yung f of A plus H natin plus minus f of A over ng H natin. Later, gagamitin natin to dun sa mga problems natin para mas madali natin siyang maintindihan. So we have here the derivative of f of X with respect to X is the function of f apostrophe X. Ito yung first derivative natin, ginagamit natin siya as first derivative, is defined as yung f apostrophe X natin is the limit where H is approaching 0. We have yung f of X plus H minus f of X over ng H. Or we have yung limit where H is approaching 0. We have the derivative of f at A, where f of A plus H minus f of A over H. So ito yung mga other na ginagamit pa pag nilalagay natin yung derivative. So we have here yung kanina, 'di ba, meron tayong pinakita na meron tayong apostrophe, which is yung dito is meron tayong f apostrophe X, where the derivative of f with respect to X. We have yung sa other naman, matatakal na rin naman natin. Kapag first derivative, sa iba is nilalagay niya is meron tayong apostrophe. Kapag second derivative, dalawang apostrophe naman siya. Since dito, yung naman sa meron tayong dy over dx, kapag naman meron tayo dito mga second derivative naman, naglalagay tayo ng number 2. So, sa susunod na mga topics, madidiscuss na rin natin yun. So, we have here, kapag meron daw tayong dy over dx, it is the derivative of y with respect to x. Kapag naman meron tayong nakita sa problem na df over dx, this is the derivative of f with respect to x. And for the d over dx or f of x or dx of f of x, so ito naman is the derivative of f of x. Kung mapapansin mo dito, hindi siya i-divide or hindi siya i-multiply. Kapag may nakita kang ganito sa problem, ibig sabihin yan is derivative. Iba-iba lang yung way kung paano siya sinusulat. So we have here yung note, yung note down natin, dx does not mean d times x. So yun na nga yun, hindi tayo magmumultiply ng d, wala tayong value for d and wala tayong value for x para sabihin natin na i-multiply siya or i-times yung dalawang letter na to. And for the dy naman, does not mean that d times y. Same lang siya. And then other notes natin, so dito naman, hindi naman ibig sabihin is magdi-divide naman tayo. So pag nakita natin meron tayong dy over dx, it does not mean that dy is, we will divide it with the dx. Or except when it is convenient to think as it is a division. Or for the df over dx, does not mean na i-divide din natin si df over ng dx natin. Ayan. And also, kapag may nakita naman tayo na d over dx multiplied dito sa f of x natin, it does not mean na i-multiply natin yung d over dx natin sa f of x. Okay, for this graph, so we have here as a sample of graph, we have yung y is equal to f of x. So dito is meron tayong sample, for example, meron tayong value ni f of x. Ito yung nature ng graph natin. So dito naman sa second graph natin, we have the derivative is the slope of the original function. So kapag meron tayo nakikita dito na point, yung parang bilog dito and meron ito, ito yung na-discuss before na we have yung jump na line. So dito, we have yung point na to, yung may colored siya. It is the derivative is defined at the endpoints of the function on the closed interval. So, iyan siya. Ganyan yung magiging itsura ng graph natin. Then, since alam na natin kung ano yung formula na gagamitin natin, ito na yung way para gamitin yung long method natin para makapag-derive tayo. For this problem, we have yung y is equal to x squared minus 3. So, yung formula natin, gagamitin natin siya dito, which is yung babalikan natin yung formula natin. So, sabihin natin, yung formula natin is we have yung f apostrophe x where yung limit natin is h approaching 0, we have the f of x plus h minus f of x over ng h. Itong formula na to, ito yung gagamitin natin for the derivation. Okay, for this problem, we have yung y is equal to x squared minus 3. So, ang gagamitin pa rin natin dito limit is we have yung limit where h is approaching 0. And for this problem, papalitan lang natin yung value. So, we have here yung x plus h kanina na naka-squared. So, we have here yung x squared plus h squared minus yung value natin ng 3 and yung value dito ng f of x natin or yung y natin, which is we have yung x squared minus 3 over ng h. And i-expand lang natin itong formula na to, yung x plus h natin na naka-raise sa squared. So we have here the x squared plus 2xh plus h squared. And itong value na to, since we have yung 3, and kapag minultiply natin yung x squared sa negative, we have yung negative x squared. And kapag minultiply natin yung negative sa negative 3, we have yung value ng positive. Positive na to. Positive 3. So, makakancel na tong negative 3. Positive na siya. And itong negative 3. So, yung next natin na equation, we have here yung x squared plus 2xh plus h squared minus ng x squared over ng h. Since isi-simplify natin yung problem, since we have here the x squared and the negative x squared, kakancel na lang natin siya. So, minus na siya, 0 na rin siya. And since meron tayong denominator na h, pwede tayong mag-cancel ng isang h for the 2xh and isang h for the h squared. Therefore, yung y prime natin is equal to limit where h is approaching 0 is equal to 2x plus h. And then, sabi natin, yung value natin for the h is 0. So, papalitan lang natin itong value ni h ng 0. So, kaya yung first derivative ng problem natin na y is equal to x squared minus 3 is equivalent lang sa 2x. And then, kapag i-graph natin itong 2x natin, ito siya. Itong problem na to. Let's say ang value natin ng x is 1. So, ito yung 1 natin. Times natin ng, since 2x siya, 2 times 1, we have yung 2. So, dito lang siya, dito sa point na to. Possible na itong point na to. Let's say naman, sabihin, ang value natin ng x is 2. So, ito yung value ng 2 natin. 2 times 2 is 4. So, we have here yung value ng 2. And so on. Kaya tayo nakagawa ng isang straight line dito. Okay, for this problem, we have the f of x is equal to 2x squared minus 16x plus 35. So, ang solution natin is same pa rin sa ginawa natin na problem kanina. So, kailangan natin muna ma-identify ano ba yung formula na gagamitin natin. So, for this problem, we have yung f of x, f apostrophe x or yung first derivative natin where equal siya sa limit where h is approaching 0 is equal dun sa f of x plus h minus f of x over ng h. So, same lang siya. Yung first natin, ito, f of x plus h, gagamitin natin siya for this problem. So, we have yung 2 times the x plus h, open and close parenthesis, squared minus yung 16 natin, multiplied by the x plus h, plus yung 35. And yung i-minus natin sa f of x. Yung f of x natin is 2x squared minus 16x plus 35. And yung denominator natin ng h. And same lang din dun sa problem natin kanina. So, isi-simplify natin itong problem na to para makuha natin yung exact value ng first derivative natin. So, yun. Yung value natin kanina is i-multiply natin if applicable. So, we have here 2x squared plus 4xh plus 2h squared minus 16x minus 16h plus 35 minus 2x squared plus 16x minus 35 over h. So, lahat ng value ng x squared, ano ba yung value natin ng x squared dito? So, we have yung x squared natin is meron tayong 2x squared at saka minus 2x squared. So, kapag minus natin siya, so makakancel na itong value na to. For the 4x each, wala naman siyang same value. So, matitira siya. For the 2h squared is wala rin naman siya. So, we have here yung 16x. So, same lang na meron tayong negative 16x plus 16x. Cancelled na rin to since 0 lang yung value niya. And for the minus h, isa lang naman siya. So, retain pa rin to. Plus 35 and minus 35. So, ito is equivalent lang din as 0. So, therefore, yung value natin na next is we have yung 4xh plus 2h squared minus 16h over h. And after nun, pwede natin tong ilabas yung value. Since lahat naman siya is may value ng h, pwede natin siyang ilabas or if-factor natin siya. Therefore, we have here yung h multiplied by the 4x plus 2h minus 16. And since ganyan yung problem natin, we have the denominator and numerator ng h, pwede na natin tong i-cancel. And for this problem, ang limit na lang natin is we have the 4x plus 2h minus 16. And since meron pa tayo ditong remaining na h na kailangan is ang value natin ng h is 0, so papalitan natin to ng value ng 0. Kaya yung value ng 2h is equivalent na to sa 0. Kaya ang first derivative natin for the problem is we have yung 4x minus 16. This problem, so kung mapapansin mo, magkakaiba lang siya ng letters na ginagamit pero halos same lang naman yung ginagamit natin na formula. Dito, we have yung value kanina na f of x ang ginagamit natin. For this problem naman, g of t yung ginagamit natin. So, kukunin daw natin yung first derivative where yung value natin na hahanapin is we have the g of t is equal to t over the t plus 1. So for the first derivative, same lang, gagamitin natin yung formula kanina. We have the limit where h is approaching 0. We have g multiplied by the t plus h minus yung gt natin over ng h. And then gamitin na natin itong given natin for the gt is equal to t over t plus 1. We have yung limit natin where h is approaching 0. We have the 1 over h multiplied by the t plus h over t plus h plus 1 minus yung gt natin na t over t plus 1. Ayan. So, for this problem, ayan na yung gagamitin natin. We have here yung for the first derivative, we have the 1 over h, t plus h multiplied din sa t plus 1 natin, minus ng t times ng t plus h plus 1 over yung t plus h natin plus 1 multiplied by t plus 1. And itong problem na to is isi-simplify lang din natin. Same lang dun sa dalawang problem natin na diniscuss. Therefore, kapag simplify na natin, we have here the limit where h is approaching 0. 1 over h multiplied by dun sa h over t plus h plus 1 multiplied by t plus 1. And after nun, since yung first natin na problem is itong problem na to is we have yung parehong h. Meron tayo ditong numerator na h and meron tayo ditong denominator na h. Pwede natin siyang tanggalin. Kapag na-cancel na natin yung h na yon, we have here yung limit natin na 1 over t plus h plus 1 multiplied by the t plus 1. And since we have yung value natin ng h as 0, ito is, papalitan lang natin ng value ng 0. And we have here 1 over t plus 1 multiplied by t plus 1 or equivalent yung denominator natin sa t plus 1 squared. Therefore, ang first derivative natin for this problem is 1 over open parenthesis t plus 1 close parenthesis raised to 2. Okay, next na problem na tayo kung walang question. For this problem naman, meron pa rin tayong same ng formula na ginagamit, pero for this problem, gagamit naman tayo ng z, and yung problem na given natin is meron na siyang square root. So we have here the r of z is equal to square root of 5z minus 8. So same lang, kunin natin yung first derivative. First derivative na yung limit natin, yung x natin is sa f of x natin is magiging r of z na siya. So we have here r multiplied by the z plus h minus yung rz over yung h natin. So gagamitin na natin yung itong problem natin. We have here the limit where h is approaching 0. We have yung square root 5 multiplied by z plus h minus ng ng 8 minus ng r of z natin, which is the square root of 5z over minus 8 over the h. And then since ganito yung problem natin, i-multiply natin siya both side ng numerator natin para ma-simplify natin siya. So ito yung problem natin na minultiply sa numerator. So kapag nag-multiply tayo ng parehong may square root, so makakancel na yung square root natin. So therefore, yung next natin, we have yung limit of h minus ng 0. We have here yung 5z na lang dahil wala na yung mga square root natin. 5z plus 5h minus ng 8 minus dun sa r of z natin na wala ng square root, which is 5z minus 8. And yung denominator natin, we have yung h multiplied by the square root of 5 multiplied by z plus h minus 8 plus yung square root natin ng 5z minus 8. And then, for the numerator natin, since yung value natin ng z dito is we have yung 5z, and kapag minultiply natin itong 5z sa negative, 5z minus 5z is 0 na lang to. For the 5h, wala naman tayo minus dito. For this naman, we have yung negative 8. Yung negative 8 natin na minultiply sa negative is positive. So, negative 8 plus 8 is equivalent sa 0. So, for the numerator, we have the 5h na lang. Ito na lang natira. And for the denominator, same pa rin tayo ng denominator. And then after that, so we have here yung sa limit natin, again, for the limit, isi-simplify lang natin siya. Tatanggalin lang natin yung value, i-convert natin yung value ng h into 0. So we have here yung value ng h natin, which is equivalent sa 0. So therefore, we have yung 5 over the square root of 5z minus ng 8 natin plus yung 5z minus ng 8. Or equivalent ito, yung denominator natin, into 2 square root of 5z minus 8. So therefore, ang first derivative natin for this problem is we have the 5 over 2 square root of 5z minus 8. For this problem naman, kung kanina gumamit tayo ng square root, and then sa other problem natin, gumamit tayo ng other letters or variable. For this problem, we have naman yung absolute value naman yung ginamit natin. So, determine daw natin yung f prime of x of 0 for the f of x is equal to the absolute value of x. So, we have here yung f prime of 0. Same lang ng formula natin na gagamitin. So, we have the f of 0 plus h minus f of 0 over the h. So, gagamitin lang natin yung value ng f of x of f of x. We have the limit where h is 0. We have yung absolute value ng 0 plus h minus yung 0 natin over h. And isi-simplify lang natin itong value where we have yung absolute value ng h over ng h where h is approaching 0. So dito, hindi siya possible kasi magiging denominator natin is 0. So hindi natin siya makukuha. So therefore, we have here yung range niya na we have yung h where yung h natin, if yung h natin is greater than or equal sa 0, and we have yung negative h as if yung h natin is less than 0. So may category tayo dito na if yung limit natin is into negative or approaching 0 negative, we have the negative h over ng h natin. For example, is we have yung limit as negative 1 kasi nga less than siya ng 0. Therefore, yung limit natin is negative 1. And then, nag-sample din tayo dito na yung sa right-hand side naman natin where yung meron tayong 0 positive, what if mas mataas naman siya or greater than naman siya sa 0? So, we have here the limit of 1 where h is approaching 0 positive, yung value natin dito is 1. So, one side limits are different. Kasi nga, ito yung negative na side is yung left-hand side and itong side na to is yung right-hand side. If the limit does not exist, then the derivative does not exist either. So, iyon yung magiging answer natin for this problem. Okay, for this naman, we have the function of f of x is called the differentiable at x is equal to a. If f apostrophe a exists and f of x is called differentiable on an interval if the derivative exists for each point in that interval. So a function is differentiable if it has a derivative everywhere in its domain. It must be continuous and smooth. Functions on closed intervals must have one-sided derivative defined at the endpoints. So ito lang yung mga other examples to be differentiable. A function must be continuous and smooth daw. So for the first example, we have here yung f of x is equal to the absolute value of x. So ito yung example ng graph niya. And we also have here yung sa f of x where x is raised to 2 over 3. Ito naman yung magiging graph niya. And we have here naman yung isang f of x natin, cube root of x, vertical tangent naman yung magiging graph niya. And ito is, we have naman for the f of x where yung negative 1 natin, if x is less than 0, and we have the 1 for the x is greater than or equal to 0, we have the continuity. So, yan. Yan lang yung mga example ng graph. Okay. For the two theorems naman is, ito lang yung example natin. If mayroon tayong kinuha na first derivative na equal siya sa 1/2, and we have yung first derivative din ng b where we have yung 3. So if a and b are any 2 points in an interval of which f is differentiable, then yung f prime natin takes only value between yung f of a natin, f prime a, and yung f prime b. So ito lang yung pinapakita sa kanya.